Forward DEF System Overview. The main components of the DEF system include the DEF tank, DEF header, DEF pump, also referred to as DEF supply module, decomposition reactor tube, and SCR catalyst. You start with adding diesel exhaust fluid, or DEF, to the DEF tank, but that is only just the beginning. Inside the tank, the level, temperature, and concentration of the DEF is monitored by the DEF header. DEF is pulled through the header from the tank by the DEF pump for injection into the exhaust via a DEF injector. The DEF pump generates a continuous flow of DEF to ensure the injector always has a pressurized supply of DEF. Only a portion of the DEF circulated is pressurized for injection. Excess DEF is returned to the tank for recirculation. The heat in the exhaust breaks the DEF down into ammonia. Ammonia is reacted in the SCR catalyst with nitrogen oxide in the exhaust stream to reduce nitrogen oxide emissions. The next section focuses on operation and supporting systems related to each component with more detail. Detailed review of system components. The DEF tank is located and designed to protect the DEF from heat and sunlight. It is designed to hold approximately 4 gallons of usable DEF. On average, for every tank of fuel, the machine will consume half a gallon of DEF. The DEF tank has a DEF header mounted to the top of the tank. The primary function of the DEF header is to monitor DEF level, temperature, urea concentration, and to detect contamination. The header communicates DEF condition to the engine ECM. Any of these monitored conditions can influence system operation, and if out of specification, will generate fault codes. The DEF header also includes a tube extending near the bottom of the tank where the fluid is drawn through a filter to supply the DEF pump. The DEF pump circulates DEF to and from the tank via insulated DEF lines. These lines are electrically heated by the engine ECM in cold conditions to prevent DEF from freezing in the lines. The DEF pump utilizes some of this circulating flow to pressurize the line feeding the DEF injector. The DEF injector is controlled by the ECM to atomize DEF into the DRT, decomposition reactor tube, to mix with the exhaust stream. To meet EPA requirements, the system will limit vehicle operation as the DEF level approaches 0. After the DEF level reaches 0%, the engine will be limited to low idle. Decomposition reactor tube, DRT, mixing tube. The DRT and exhaust hardware are insulated to retain heat. Higher temperatures help prevent unwanted deposits generated from urea from accumulating within the tubing and catalyst. Immediately after engine shutdown, the DEF injector opens and the pump activates to pull air into the lines and purge DEF back to the tank through both the tank supply and return lines. This ensures that a large amount of DEF does not become frozen within the lines. In cold ambient conditions, a heating loop integrated into the DEF header carries engine coolant to thaw DEF and maintain temperature above freezing. In warm conditions, the engine coolant is shut off by an electronically activated valve in the engine coolant supply line. Note, though we are using coolant, the purpose of the coolant loop in the DEF tank is to elevate temperatures. Engine coolant also circulates in separate lines to cool the DEF injector. Note, the valve cycles upon each startup as part of a system check and will then be opened or closed depending on ambient conditions. This concludes the high-level overview of the forward DEF system. For additional information, refer to the DEF system and after-treatment sections of the machine's operator manual. For more information, contact JLG customer support at 1-877-JLG-LIFT or by going online at www.jlg.com.